Good morning, students. This session is for ICC Class 10 revision. So आज का जो सेशन है दिस इज फॉर द रिवीजन ऑफ द फर्स्ट टू चैप्टर फोर्स एंड वर्क एनर्जी पावर. सो फोर्स में देखो आज का जो रिवीजन है दिस रिवीजन इज बेसिकली फॉर एग्जाम ओरिएंटेड. सो डेफिनेटली इन ईच ऑफ द आवर सेशन आवर फोकस इज टू so that you can give a good exam like the common mistakes what we are doing. For example फोर्स में क्या रहता है कि फोर्स न्यूटन फर्स्ट सेकंड थर्ड लॉ अभी तो एग्जाम पार्ट में नहीं है बट मोमेंटम जो है दैट्स वेरी इंपॉर्टेंट. सो मोमेंटम क्या होता है? मोमेंटम मीन्स द प्रोडक्ट ऑफ मास एंड वेलोसिटी. दिस इज वेरी इंपॉर्टेंट and we are also getting confused the relation between momentum और kinetic energy में relation क्या होता है. So let me show you for that part. मोमेंटम में मोमेंटम का सिंबल क्या होता है? P होता है, ठीक है ना. सो P इज ए वेक्टर क्वांटिटी. P इज इक्वल टू मास इनटू वेलोसिटी. वेलोसिटी इज ए वेक्टर क्वांटिटी, P इज ए वेक्टर क्वांटिटी. सो ये हो गया मोमेंटम. ना यूनिट ऑफ मोमेंटम क्या होगा एसआई में? मास का. सो दे आर सिटिंग टुगेदर. सो मास का यूनिट होता है केजी और वेलोसिटी का क्या होता है? मीटर पर सेकेंड. सो मोमेंटम का यूनिट हो गया केजी मीटर पर सेकेंड. दिस इज फॉर एसआई. अभी सीजीएस में कैसे होगा? ग्राम सेंटीमीटर पर सेकेंड. सो ये हो गया यूनिट्स वाला बात. नाउ रिलेशन बिटवीन मोमेंटम एंड द काइनेटिक एनर्जी. सो काइनेटिक एनर्जी का सिंबल क्या है? काइनेटिक सिंबल K इज इक्वल टू हाफ एम वी स्क्वायर. M is the mass of the object and V is the velocity. Now what does it mean? What is the real life example? A football ball, rolling in the ground, or cricket ball. Until their motion, they are having the kinetic energies. Motion stop. So velocity 0, K 0. So kinetic energy will exist till there is a motion of the object. There is no motion, no kinetic energy. Now also you must know, right, the conservation of energies. Like kinetic, you have two energies you have to consider. One is kinetic energy, otherwise is the potential energy. So you have that part, like you have to prove the total energy conserved in a vertical motions. So उसमें क्या होगा? We have to calculate the total energy whenever some object is here. It is not moving, right? So velocity is 0. So at this state kinetic energy 0 हो गया है. इसका एनर्जी बाकी क्या रहा? पोटेंशियल एनर्जी है. सो पोटेंशियल एनर्जी का फॉर्मूला क्या होता है? mgh. mgh मतलब we are, it is in a certain height and height is in relative matters. We have to take some height 0. There is no absolute, like earth surface is the 0 height. So something जो अर्थ सरफेस से 10 मीटर ऊंचाई पे है उसका एज वाला हो गया 10 meters. Clear? So if something I am pulling from earth surface to the 10-meter height, उसका पोटेंशियल एनर्जी क्या होगा? mgh. m फॉर मास, g फॉर एक्सेलरेशन ड्यू टू ग्रेविटी, h फॉर हाइट. सो ये जो पोटेंशियल एनर्जी स्टोर हो इसका यूनिट क्या होता है? जूल. अभी जब वो व्हेन आई रिलीज दिस वन इट विल हैव ए फ्री फॉल एंड इट विल टच द ग्राउंड विथ एन हाई वेलोसिटी. सो वेलोसिटी का लिमिट क्या होगा? इफ 1000 जूल था उसका पोटेंशियल एनर्जी, जब वो ग्राउंड टच करेगा वो पूरा 1000 जूल काइनेटिक एनर्जी में कन्वर्ट होगा by making potential energy 0, right? So उसका maximum velocity कैसे, how we are going to calculate that? By equating the motion like so. Let's say this is the top, here is potential energy. The total energy will convert to kinetic energy here, half m v square. So if this was 1000 joule, so kinetic energy will be 1000 joule. अगर हम if we have the mass, we'll get the velocity. That's it. Okay. Now there is a thing like what is the relation between K and P, like kinetic energy and potential energy. So kinetic energy means half m v square. So potential and the P momentum is mv. So we have to make a relation. What we are going to do? We are going to do like this. K is equal to half mv square by m. So I am taking one m, numerator denominator. So it's become half p square by m. So it's becoming p is equal to p square is equal to 2 mk or p is equal to root over of m 2 mk. That's it. So this is the relation between the momentum and the kinetic energy. दिस ये बहुत इंपॉर्टेंट है बिकॉज इनमें से बहुत सारे क्वेश्चंस आ जाता है, ठीक है ना। अभी और एक चीज बहुत इंपॉर्टेंट होता है कि वर्क एनर्जी थ्योरम। सो वर्क एंड एनर्जी आर इक्विवेलेंट, वर्क एंड एनर्जी आर इक्विवेलेंट. Let's take an example, like whenever I told you that someone catching a ball, okay, so the ball is coming in high speed with a high kinetic energy, right? So I stop the ball, so ball stop, so there is a change in kinetic energy. And what happened, how does it change? I did some work, I did some effort. If ये कैसे पता, अगर हम पूरा दिन बॉल पकड़ते रहे, I will be hungry because I am spending my energy through work done. So kinetic energy reduced हो रहा है, उसका equivalent work done we are doing. So work energy theory में ही होता है कि whatever work we are doing, that is converted to either kinetic energy or potential energy. Suppose we are picking up something, like in a flat some work is going on, so people are taking the whatever the materials from first floor to third floor. If they're doing this whole day, they will be faint, like because they're doing work done, and this work done getting stored as a potential energy in the third floor. So ये भी प्रूव करते हैं कि वर्क एंड एनर्जी आर इक्विवेलेंट. यही फॉर्मूला है कि वर्क एनर्जी थ्योरम क्या बोलता है, सी चेंज इन काइनेटिक एनर्जी इज इक्विवेलेंट टू द वर्क डन, राइट. दैट मीन्स वर्क इज इक्वल टू के फाइनल माइनस के एफ, मीन्स फाइनल पोटेंशियल एनर्जी, फाइनल काइनेटिक एनर्जी माइनस initial kinetic energy. So it will be like half mv square minus half mu square. So v is the final velocity of the object, u is the initial velocity. अभी ये होता है work done. So it can be increasing or decreasing. Suppose I am just just making a ball to move and giving higher velocity. I just shot on a running ball. So I did some work done and velocity increased. And I am trying to stop a ball. So I did some work done to reduce the velocity. So work energy means the work is equivalent to the change in kinetic energy. Okay? So this is very important. Now, one more flavor of work done is how to get the derivation of potential energy. How we are getting mgh. So mgh means, so we are having a object here, this is ground zero, height is equal to 0. Now what are the force acting on this object? F is equal to mg, right, is equal to w, the weight of the object acting downward, weight of the object acting downward. Now if I am picking up this object to a height h here, okay, height h here, so what is happening, the force is in this direction, I did a work done, W is equal to force into displacement, F dot S, right, force into displacement. So here force is what, force is mg and displacement is the height h. Let me take a small height, so h, so work done is equal to mgh. So this work done stored as a potential energy, so I got the formula of potential energy. That's it. Okay, so this way we are deriving the formula of potential energy. Okay, okay, so these are the things it will help you for your exam, like you'll get different kind of questions, and these are like conservation of energy is very important. You'll get some questions where you are calculating the potential energy and kinetic energy, you have to equalize the things. Okay, fine. Now let's focus on the first chapter, force. So fourth chapter, we already know the Newton first law, second law, third law. So second law is that rate of change of momentum of an object is proportional to the force applied on it, and the change of momentum will happen in the direction of the force. Fine. Now here we will be studying the rotational motions, like moment of a force. Means sometimes what happened, we are we are opening the door. So what happened, the door, there is no translatory motions, it's only rotational motions. We are rotating something, like we are just if you rotate a globe, so what happened, that globe is rotating but it's not changing the positions, right? So it's happened here also. Let's say there is a door and I am opening the door, so there will be a angular motions, and this is the axis of rotation. In the door there is a hinge, right, the fixed point. So the door is just rotating around the fixed point. So this is a concept called rotation. Something, so rotation means angular displacement. Displacement happen, but angular. Theta changes, angular displacement, but no translatory motion is happening. So this is called rotatory motion. Now moment of force. Moment of force means we are applying a force to the door and door is having some turning. So that's called moment of force. Force into perpendicular distance from the point of object. Like here, if I show you, like I am applying a force here, and the perpendicular distance from the fixed point to the point of application of force is D, the moment of force will be F into D. F into D. So D is the perpendicular distance between the fixed point and the point of application of force. So this is very important. So moment of force. Now what is the unit of moment of, so formula is force into distance. The perpendicular distance from the fixed point, as I told you, force and perpendicular distance from the fixed point or hinge point. Now what will be the the moment of force का one more name is that's called torque. और एक नेम होता है टॉर्क बोलता है उसको, ठीक है ना. और मोमेंट ऑफ फोर्स, उसका यूनिट क्या होगा, फोर्स इंटू डिस न्यूटन इंटू मीटर, उसका भी होगा न्यूटन मीटर और डाइन सेंटीमीटर, राइट. नाउ नेक्स्ट इज द कपल. Couple means the very example. Let me show you, like if I open this bottle, like I am just giving equal force with my two finger, right? Okay, so what's happened, I am giving a force, and that rotation is happening. So this is called couple. So two equal forces we are applying into different directions, so it's creating a couple. So like the driver, whenever we are rotating, whenever we are having some drive, so in the steerings we are applying this rotation like coupling force. Okay, opening any water tap, right? Similarly, so there we are applying two forces, equal forces in opposite directions, and to the in a straight line, like point A and point B. If I am applying a force in this direction, one more force B in this direction, so couple will be like any of the force and the distance between this B to A, the perpendicular distance between the forces. So this is called couple. So this is also very important. Now next is the equilibrium of bodies. Equilibrium means what? So objects will be in the steady state, right? Object will be in the steady state means static equilibrium and the dynamic equilibrium. So static equilibrium means net result will be zero. So something like this board is here static, it's not moving. If I am applying a force like this, if you see, even that also is not moving. So I am trying to I am giving force, but I am not able to move this board. So it will be in the static equilibrium, because whenever I am giving a force like this, so I am getting a reaction force also. The net result is zero. So net force zero, object is in rest, called static equilibrium. And one more is the dynamic equilibrium. Dynamic means object will be in motion, but even that state also net force could be zero. Some object is rolling in the floor, something is rotating, right? So so it is in uniform velocity. Example is the uniform velocity. Velocity is not getting changed. Something is rolling in the floor. Some car is moving on the road, but with uniform velocity. Velocity is not getting changed. That means net force applied on that object is zero, right? So dynamic equilibrium is like same state of motion when the net force acting on the body is the zero. And now force means two part. Now one is the the translatory force, other is the rotational force, the moment of the force. And will come that now it's coming principle of moments. Principle of moments के example क्या होता है? Whenever we are taking the manual weighing, right? The old weighing technology we are having some like we are taking the food share, whatever the item, and the weight there. So it's in balance. It's balance means we are saying that okay, we are okay, 1 kilo 2 kilo जो भी होगा. So now they are utilizing the technology of the principle of moments. So moments balance होता है इधर. अगर balance नहीं होगा क्या होगा? पूरा rotation चालू हो जाएगा. Everything will be messed up. Same thing happen in the the whenever we are in a boat, in a like sea, the boats are going. So sometimes accidents are happening. Even in boat also, if you go to small boats in small cities, right, they are saying that idhar baithe udhar baithe. Kyun? Because the net force should be balance the boat. If few people are sitting more in a make a cluster, so boat will rotate. Good rotation happen and it will be a danger, right? So there also taking the principle of moments technology here, right? So definitely you are going to get some questions on principle of moments, okay, and we will have some some numerical solve here. So and it is going to come this kind of questions you will be getting, right? So maybe in a numerical way, maybe in conceptual way, right? Okay. So for these chapters, so important part is the moment of the force. It's a rotation force into distance, perpendicular distance. Okay, unit is Newton meter or 9 centimeter. Next is the what is clockwise and what is anti-clockwise movement, right? So clockwise means some things I'm now. Let us go to a deep dive now for this part. Okay, let's there is a balance point here. Now we are hanging something of weight, let's say F1. F1 is equal to mg, whatever, right? Now this will be the distance L1 and this will be F1. So what happened? There will be motion like this, rotational motion. So this is the anti-clockwise. So you have to remember clockwise means always like this, clockwise this. So if I am giving a load here, I am giving a load here, so what happen, this load will try to make a clockwise movement. So this is the clockwise movement, this is the anti-clockwise. So this depends on, let's say this is the reference point we have, right? From this point will decide your equilibrium. We have to set a point. We have to understand with respect to which point we are trying to calculate the equilibrium positions. So this may be so in a scale point. Normally they are taking midpoint, but if they ask you to calculate the the equilibrium from this point, then what you are going to do? You have to understand what is the distance of this and what is the distance of this. So calculating distance with respect to the equilibrium point is very important. We have to understand that the which point I have to take. Normally they are mentioning the points definitely, but we have to take that. So we will calculate the length means from the reference point the distance of the load. Distance of the load. If it is F1 or W1, and distance is this is X1, this is W1. So moment will be like clockwise. The value of the moment W1 X1. This is very important, right? Okay. Fine. So principle as moment is clear, I think, for both of you, right? Okay. So for this chapter, these are the things like equilibrium of bodies, moment of the force, and the basic concept. Now the chapter 2 is the work, energy, and power, right? Work, energy, and power. So for this chapter in class 10, you will have one additional thing, that is the cos theta, right? It was not in the junior classes. So definition of work is Fs cos theta. Fs cos theta. So work is a scalar quantity, force is a vector, and this S is a vector quantity. Okay. So this is actually called the dot product of vectors. Two vectors having dot product. Okay. So W is equal to actually F dot S. Two vector is having dot product, and any dot product we are getting the scalar output. Okay. Now what is the role of theta over here? So theta का role क्या है? So I'll show you 2-3 cases. This is a straight line. I'm applying force in this direction. So this is the force vector and object is moving in S, the displacement. So क्या होगा? The angle between these two, theta is equal to 0 degree. ठीक है? इधर theta हो गया 0 degree, because these two vectors are parallel. Now, if I am giving force and object is moving in this direction, yes, displacement इधर हो रहा है, तो क्या होगा? So angle will be theta. Angle between the force vector and the displacement vector is theta. Okay, that time, so let's say theta is equal to 30 degree. So work done क्या होगा? W is equal to Fs cos theta. So theta is 30 degree. Okay, so cos theta factor is very important. Why? Because we are getting maximum work when theta 0. Means force जिधर apply हो रहा है उधर ही object is going in the same straight line. So work done maximum. जैसे घर में होता है, we are pushing some table chairs, maximum होता है, right? अभी theta, when theta will be 90 degree, theta will be 90 degree, work done will be 0 because cos theta cos 90 डिग्री का वैल्यू होता है 0 डिग्री, cos 90 डिग्री का वैल्यू होता है 0, इसलिए वर्क डन 0. सो वर्क डन 0 कब होता है कि डिस्प्लेसमेंट एंड फोर्स ऑफ एप्लीकेशन इज ऑन परपेंडिकुलर टू ईच अदर. सीधा भूलने का बात कुछ नहीं है बिकॉज थीटा 90 मतलब cos 90 डिग्री 0, वर्क डन 0 होगा. तो इसका एग्जांपल क्या होता है, लाइक we are moving something like this and the force is applying downwards. There is an attach, like the famous example, like some pulley, or maybe we are taking something in our head and moving. So what happened, that objects, that weight acting downward and displacement in this direction. So angle between the displacement and the force is 90 degree, work done 0. वर्क डन 0. अभी पॉजिटिव वर्क मतलब क्या होता है, थीटा इज लेस देन 90 डिग्री. थीटा इज 0 to 90 में वर्क डन पॉजिटिव होता है. 0 डिग्री से 90 तक टिल लेस देन 90 वर्क डन पॉजिटिव. एंड वर्क डन नेगेटिव कब होता है, when theta is greater than 90 degree, okay, and less than equal to 180 degree. Here work done is become negative work done because cos theta का वैल्यू 90 to 180 में नेगेटिव होता है. ये मैथमेटिकल एक्सप्रेशन. और एक्चुअल में क्या होता है कि when your displacement is happening, let's say example is the frictional force, okay. 180 डिग्री का एक एग्जांपल देता हूँ. There is an object, I am applying a force and object is moving in this direction. And opposite direction we will be having a frictional force. फ्रिक्शन बोल के एक फोर्स होते हैं जो मोशन का ऑपोजिट में काम करते हैं. एवरी टाइम whenever there is a motion happening, उसका ऑपोजिट में on the point of contact of the object with the surface, friction force is there, so it's acting opposite. So angle between this friction force and the displacement कितना हो गया, ये हो गया 180 डिग्री. सो W हो गया माइनस एफएस. ये बोलते हैं नेगेटिव वर्क डन when displacement and force as in opposite direction, 180 degree होगी. Okay, so this is about the work done. Now next part will be the work energy. तो हो गया है. तो energy part we are discussing now, conservation of energies, right, and the expressions of the kinetic energy. I think you have it, right? So how does it came? Kinetic energy is equal to half m v square. ये कैसे आ रहा है, ठीक है ना. सो वी आर हैविंग एन ऑब्जेक्ट हेयर, वी आर हैविंग एन ऑब्जेक्ट मास m, इनिशियल वेलोसिटी वाज u, फाइनल वेलोसिटी इज v. फाइन. आई एम अप्लाइंग ए फोर्स. ये एक फुटबॉल है, फुटबॉल को मैंने फोर्स अप्लाई किया, उसका इनिशियल वेलोसिटी u था, इंक्रीज होकर हो गया v. सो इधर क्या हुआ, नाउ विल सेट द इक्वेशन ऑफ मोशंस. इक्वेशन ऑफ मोशन क्या है कि नाउ आई एम अप्लाइंग ए फोर्स मींस इधर डिस्प्लेसमेंट हो गया s, so force is equal to mass into acceleration according to Newton's second law. Now what is the acceleration here? V minus u by t. Acceleration means rate of change of velocity with respect to time. ये नॉलेज तुम्हारे साथ चाहिए because of the exam, right? So acceleration हो गया. So force means mass into acceleration. Now I will just write down here force is equal to m then v minus u by t. ये हो गया. Now one more equation of motions is v square is equal to u square plus 2as. Second equation of motion, right? So it's a final velocity, initial velocity, relation between final initial velocity with the displacement. Acceleration positive है. So इधर से क्या आता है, 2as is equal to v square minus u square, और I am getting as is equal to v square minus u square by 2. as is equal to v square u square. Now ये जो ऑब्जेक्ट मूवमेंट हुआ, इधर वर्क डन कितना हुआ बताओ. वर्क डन फोर्स इनटू डिस्प्लेसमेंट. सो वर्क डन इज इक्वल टू एफ एस. सो फोर्स हो गया ए में, एस इज एस, सो एस आई एम रिप्लेसिंग हियर, सो इट विल बी हाफ एम v square minus u square. Okay, so this is the expression of the change in kinetic energy. Now if I am having initial velocity was 0, so u is gone, so it will be half m v square. Okay, so this is the expression of kinetic energy. So work done, make it in kinetic. So it's an half mv squared. So it's the expression of kinetic energy. So एक derivation होता है. We must know these things. Different questions. Somewhere you can get this shit, right? ठीक है. So we now conservation of energy. The last part of the work done. What energy, like, let me show you here. So I am throwing a ball, I am releasing a ball from here. Okay, let's say I am making a free fall of an object from here. Initial it was at rest here, so initial velocity u will be 0. An object is in h, height h. So this is the ground. Let me take, this is ground and this is the, I took the object in the height h. At this state, object is at rest. I am just releasing the object. Now we'll calculate total energy in 3 points. A, B is the midpoint or any arbitrary point, and C. We'll calculate and prove that total mechanical energy conserved in the whole journey. This is the your derivation or proof of the proof conservation of mechanical energy जो है वो वाला है. So now what are the symbols, like total energy, let's say T, it's called kinetic plus potential. U is for potential, K for kinetic, T for total energy. हो गया. Now at this point A, what happened? Point A, Ka is 0. No velocity, kinetic energy 0. U में कितना होगा? mgh, because total height I am taking here. So total energy Ta, what happened? 0 plus mgh, it's coming mgh. So at this point Ta, total energy we receive mgh. Okay. Now at the point B, what is going to happen at B? Let me take this B point is in from x distance from point A. Object moved A to B x distance आ गया. तो when object is starting, what is the physics behind this? क्या हो रहा है इधर? Actually it's a free fall. Free fall means vertical motion. Vertical motion means acceleration due to gravity will come. So इसका acceleration कौन सा है? G. Earth gravitation वाला acceleration हो गया. So this gravity will pull it all time. So it will pull and वो acceleration है G. It's a positive direction of G. अर्थ ग्रेविटी का पुलिंग फोर्स डाउनवर्ड होता है, तो whenever something is downward motion, G will be positive. अगर कोई अपवर्ड जा रहा है, G acceleration will be negative. So in our case, G is positive, right? So point A is 0. Now here क्या होगा? Equation E square is equal to E square plus 2AS, the basic equation. Now V, let me take V is the velocity at point B. So ये हो गया VB square is equal to U तो 0 है, तो ये 0 हो गया. A, I replace A is equal to G here. Acceleration is equal to G, right? A is equal to G. So 2G, S means X. So energy I have received 2Gx हो गया. Now what will be the kinetic energy at this point? Kb is equal to half m and this one 2Gx. So it's become mgx. So mgx is the kinetic energy at point B. And what is the potential energy at point B? So potential will calculate the height of B from the ground. Height कितना होता है इधर? h minus x. Height is h minus x from B to C. So potential हो गया mg h minus x, right? Now if I add these two, so total energy at point B क्या होगा? It will be okay. It will be again mgh, right? So total energy TB is equal to kb plus ub. So kb means mg x, right? And ub is mg h minus x. So total energy is coming again mgh. So at the point B, energy is same like point A. Now the last one is the point C. At the point C, what happened? That C ground 0, H is equal to 0. So at the point C, there is no potential energy because height becomes zero. Height zero हो गया. So total energy kinetic हो गया. अभी VC क्या होगा? VC square is equal to UA square plus 2AS. So VC square is U, ये तो जीरो है. Initial velocity जीरो था. So acceleration क्या है? G. S कितना हो? Total distance. It travel vertical distance h from A to C. So it is G, 2gh. So kinetic energy Kc at the point C will be half mv square, means vc square. It's again coming mgh. हो गया. So total energy is conserved. It's same with point A and point B and point C. बस यही है. So if you go and practice like this in your study during your study time, that's it. You don't have to go in a like ordinary approach. Go in the conceptual approach and practice. Right? Okay. Okay. Thank you.